who will be showing us how to use RPy. Is that right?
Yes.
Yep, for powerful analytics from Python.
Hi, I'm Rhydwyn. As said, I work in public health, doing medical data analysis. I'm going to run through a fairly basic talk on RPy, how it works, and why you'd care. My contact details are on the screen. I just need to make clear at this point that everything I say is mine. I am not here representing my organisation. Anything I talk about with my organisation is just background. How did I get here? So, why do we care? I fell in love with mathematics around the start of university. It turns out that there's a huge number of problems which you can pose in mathematics and use mathematics to solve. There's traffic conditions. You can, traffic conditions, minimising the traffic congestion, where to put traffic lights, the sequences of those lights is a mathematical optimisation problem. My slides aren't going together, so sorry about any little breaks. Infectious disease travelling through communities. If I am infected with a new strain of flu, who's most likely to get it? Well, people at this conference would be a good start, but I've spent a lot of time with some people in this conference and not a lot of time with others, so you wouldn't expect a uniform distribution of infection risk. And so epidemiologists work with mathematical models to describe this. These are two really different ideas. They're two totally different problems, but they get solved by the same branch of mathematics, that is graph theory. Whether you're representing the people you're close to or the traffic systems which are close together and therefore have a lot of flow-on effect, you use the same kind of mathematics. The problem is, we can't solve these problems without this. Mathematicians can describe the problems, but we run into the problem that they're very computationally expensive. So I ended up, as a mathematician, realising that I needed to learn computer science so that I could actually solve some of these things rather than just describe how they might be solved. But I don't have a PhD from the University of Smartass. Why do I care? Why do you want to know about R? Where would you use it? So let's say you're running a web server. There's lots of stuff on Python in the web. You might want to look at traffic pattern analysis. You might want to know when your peaks are, when your downtime is, whether you've got suspicious activity. Or you might want to, you might be working at SourceForge and want to be able to say, look, people who downloaded this program also downloaded this program, do a recommendation system. All of these kind of things are statistical models. So what is R? R is a statistical language, great, reproducible, scriptable statistical analysis. It's widely used among statisticians and it's picking up popularity at the moment. It's got the kind of user base that FOSS projects dream of. It's got active communities in different bits of the web. It's got heaps of support for new users. It's got a whole lot of documentation, really quality documentation in a lot of cases. It's open source. And it's cross-platform. It runs on everything. Well, everything that I've ever heard of. So, I'm going to talk a bit about what's being done in R. At the moment, these are some cool projects that I've come across. Statnet. Statnet is random graph modelling. These are the kind of problems we were talking about earlier in traffic conditions and in viruses. This is one of the diagrams that Statnet can produce. GenABEL. So there's heaps of work going on in genetic databases at the moment. As a medical researcher, this is really exciting. GenABEL on its website has a list of papers that have used this library to do work. 3 random ones that I grabbed. 6 novel lipid levels, so that's your blood fat level. That's a really important cardiovascular risk. So we've identified genes that are related to cardiovascular risk. That's really important. New multiple sclerosis loci. Again, another medical condition that through genetic research we can understand better and hopefully treat better. And eye colour loci, which is just cool. Finally, RGL. Uses OpenGL to create interactive 3D plots. So these are really easy to produce. Just throw your data at it and you pull up something that you can spin around, you can look at. It looks brilliant. This is a little tutorial I found on the web. Plotting the distribution of galaxies using This is a little tutorial I found on the web, plotting the distribution of galaxies in a cluster using publicly available NASA data. It's not a long tutorial. And then there's what I do. I make dentists less scary. I work for the dental hospital in Melbourne. We're looking at a procedure that takes kids who would otherwise probably have to have several sessions in a dental chair, and we're talking really young kids, like as young as 3, 4-year-olds, have several sessions in a dental chair with local anaesthetic or at least one general anaesthetic session, and we're replacing that with a technique that takes about 5 minutes per tooth, doesn't need a GA, doesn't need a drill, there are no scary sounds. So that's where I'm doing the data analysis for that project in R, and I'm really excited about that. So I thought I'd throw it in. Okay. Let's talk about a little R script before I get into RPy. This is a really simple script to produce the first 20 iterations of the Mandelbrot fractal. Okay, so this is what R looks like. Grab a library which produces GIFs, produces movable GIFs, I mean. Define some colours, define the size. We're going to have a 1200 by 1200 image. Okay, we define a sequence of complex numbers. They go from -0.8 to 0.6 in the real and -1.2 to 1.2 in the imaginary. We preset some variables, making a a three-dimensional array of filled with zeros of size 1200, 1200, and 20. We iterate to produce those 20 slides that you saw at the start, and then we write it out. Really simple, really nice way to express numerical computation. So this is great. Why worry about Python at all? Why am I here telling you about R at a Python conference? This seems a little bold. R is not a general purpose language. It should not be used as a general purpose language. In fact, when you use it as a general purpose language, things get really bad. I've done this, don't try this, it's not pretty. Some of the reasons you don't want to do it. R has a lot of data cleaning, but it's not my preferred tool. I don't think anyone would suggest you use R for web scraping, but web scraping is exactly the kind of thing you might want to do in order to get data to use, however you're using it. Beautiful Soup is a Python library that I assume most people know. Makes web scraping easier. Sourcing data. Dealing with networks, dealing with live monitoring data. R is a specific language. It doesn't care about proxies, nor should it. It doesn't care about firewalls. It doesn't do well at connecting to hardware which is producing data for you. Back in the long, long ago, I did some work for a government agency on environmental modelling. I was looking at air quality data and trying to do some long-term pattern analysis and noise reduction on that. This is the problem. Pull the data out of storage, do science to it, make the results pretty. I had about 70,000 data sets. From memory, that was about 10 years data at 5-minute intervals, and each of those data sets were about 12,000 points across Melbourne. My solution, Python to pull the data out, R to do the science, Python to make it pretty. This is what the script was, basically. Pull the data out, write the data to a CSV file, and then call a script that finds that CSV file, which writes out its own out script, which you then read in and make the results pretty. Fine, it works, no problem. So why do we care about RPy? Errors. I don't know if you've ever tried to do delicate error passing through the file system. I don't recommend it. I really don't. So this thing could fail for several reasons. You have all your normal failings, many of which we ran into, like the file not being there or problems with the network, because this was all being done on network drives. The statistical methods we were using, some of them relied on nonlinear optimization, so they occasionally wouldn't work. So as well as the standard errors, you had a whole lot of specific errors which then needed to be handled by Python going in and calling the R script again with different starting parameters. Trying to do that nicely through the file system is not good. It ran in the end. This was the build we went with, but it was a learning experience. We'll put it that way. And that better way is RPy. There are two flavours. RPy is in the process of being rewritten, and I'm going to be talking about RPy 2 just because That's what I've been working with. Either one is worth checking out if you're interested. Which one works better for you at this point? I mean, eventually RPy 2 is the way to go, and how many people here are using Python 3? So, okay. So first off, running R code in Python. This is where you've got a script. It might be a legacy script. You might be working with a statistician who doesn't use anything but R and thinks that you're ridiculous for wanting them to use something other than R. It might be because you want libraries that are only available in R, or just it's a better solution. So this is a really simple way to do it. You can just read the script in as a string, and then collect the result, and then you can pull variables out of the global environment. You can also pull variables out of specific environments within that R code. I just haven't put this here. So basically, RPy is a glue between R and Python. Our objects are exposed as incidences of Python implemented classes, and functions as bound methods. We're going to quickly go through a linear regression, line of best fit. Now, there's no reason to use RPy to do this. Python will handle this in probably half a dozen, at very minimum, different modules. But it's a nice, easy example. Was that always doing that? Okay. We import, sorry about the slides. We import an array. We import some R objects, and we import this importer. This is interesting because this allows us to read in R libraries. We set up an int vector that's just from numbers 1 to 11, and then we define R as the numbers 1 to 11, but with some noise. We then define a formula. Formulas get used all the time in R. They're the way that you describe what kind of relationship you want to model. This just says model X to Y linearly. We define an environment just so that R knows what the things in the formula refer to. We fit it. We call stats, that's our library, and we call the function LM, linear model, off that using our formula. We print it and we plot it. Pretty simple. I'll just take a moment to talk about the dragons. Some issues that I've run into that you might run into if you pick up this module. Factors. Factors get used all the time in R. They are an integer representation of a category. So it might be country of birth. So Australia gets coded as 1, UK gets coded as 2, so on and so forth. Whenever you're dealing with importing data from R, there's a good chance there'll be factors in there, and they get represented as factors in Python. R indexes from 1. You have no idea how much this has tripped me up in the last year, jumping between Python screens and R screens. This is the first element. With factors, you can't test factors as their string, although you'd like to. I'd like to. That will fail. Factors can't be compared to strings. You have to cast it. Simple, but that will trip you up. Naming conventions. This is a data frame in R. A data frame is a really commonly used form of data object. It's a two-dimensional, it's somewhat like a spreadsheet, I guess, or a matrix, but with metadata. There's no syntax in R about dots. That is just a variable name. When you move into Python, the dots are replaced with underscores because that's not something Python will cope with. It doesn't like you putting random full stops in your variable names. There are some libraries out there that have implemented both my function with an underscore and my function with a dot. I do not know why, but they have. If you try to import one of these libraries, you'll get a library error because your function names are no longer unique. Negative indices. Now, Python programmers will look at this and go, yep, last item. No. This in R will give you every element except one. So this will give you 2 to the end. Yeah, so there were a couple of conflicting things. Just be aware of them. Okay, getting to the end. References. RPy's mailing list exists. RPy is still under development. There's still a lot of work to be done, but the mailing list is lovely. It's fairly well supported. You'll generally get questions answered. RHelp's mailing list is huge. It's busy. There's a whole lot of people who are regularly answering questions on there. I've picked up a lot just for sitting on the list and watching other people make the mistakes so I don't have to. I'm going to throw in a plug for this book. If anyone is interested in getting into R, The Art of R Programming is great. Really good textbook. That's my standard one. Works better if you don't spill tea on it. RStudio is a open source IDE. It allows you to connect up to Git servers and Subversion. It's the one I use for my day-to-day work, and I thought I'd put it in there. Conclusion. There's data out there. Let's get to it. R has a great set of tools. It's got really good support. It's got huge numbers of libraries. Whatever you need to do, there's a good chance it's been done. You can get to R's libraries now without having to learn R, without having to run separate scripts. You can run this, run a script, pull it back into your main Python thing and just have that work. And as a final thing, I want to shout out Ed Schofield did a talk earlier. It was videotaped, so it'll be up there. He does a really good job of talking about the alternatives to RPy. He's of the belief that RPy we won't worry about it. We'll have all the libraries in Python. I'm not that confident, but we'll see how it goes. Maybe in 5 years I'll be standing up here going, yeah, the olden days, I used to use R. That was a bit embarrassing. We'll see. But Pandas is a Python module that's looking to do a whole lot of really cool data analysis, and stats models also has a lot of statistical stuff in it. So those are 2 things to check out if you don't want to jump into R. Okay, questions?
Thank you very much.
Hi, thanks for the talk. I guess maybe if you could elaborate a bit more on sort of that final point. I've been using Pandas and I guess kind of comparing the SciPy, NumPy, Pandas stat to the R stuff. What are the different pros and cons? Where is Python behind? My feeling is that one of the biggest advantages of R is probably the existing libraries that exist.
Yeah, absolutely.
What else is there? And just, you know.
So yeah, the existing libraries is a big thing. R's been around in different guises as well. R is based on a proprietary language called S, which was started in 74, I think. So it's been around in various guises for a while. There's a lot of work in it. I think it'll be around for a while because of that. It's quite natural for statisticians to use rather than computer scientists. So I think you'll have a lot of people coming out of the data analysis university streams who use it. I really like it. I really like the syntax, but then I'm used to it. But on the other hand, it's not a general purpose language. It doesn't have the quality of error handling that Python has. There are a lot of good reasons also to use pandas. So I think that's just down to any particular person sitting down, working out what they want to do and what the best tool for the job is then.
Thanks. A few back here.
Yeah, I was just wondering, like, do you know of any other attempts to interface other general programming languages to R? And if so, like, is R does Python have the best interface, or are there others?
I know that there are other interfaces. I'm pretty sure Perl has one. I'm pretty sure C++ has one. A lot of R, when you get down to it, a lot of the numeric libraries are written in C or Fortran, so there's a lot of interfacing there. I use Python and R. I don't have a really good it would be interesting, but I haven't really had a good reason to look. So, yeah.
I used to use R at uni, and I thought R was awesome. And it's brilliant to see that there's something that you can use, like a programming language like Python, to access R. So my two questions are: how's it structured? So you have a Python runtime, and you have R installed, and then there's this library, and it does just talk to the R binary?
Yes, that's okay. My understanding.
Yeah, and so the one thing I loved about R the most was the charts that you could pull out of it. So you could have something in Python and be exclusively in Python, and could you get charts?
Yes, you absolutely can. So there's support for both the basic charting and also for ggplot and lattice, and probably other charting languages that I haven't heard of. But yeah, other charting modules, sorry.
Yeah. And have you heard of anyone using those charts and exposing them to the web?
Oh, yeah, yeah. So I'm aware of a couple of packages. I'm not sure about exposing them to the web, but I'm aware of a number of people doing their plotting through things like ggplot for development. And I'm sure someone out there is exposing them to the web. I just can't think of any.
Cool, thanks.
So, as you mentioned, R is available on lots of different platforms. From what I understand, RPy works okay on Windows, but RPy 2 is not supported on Windows. Is that correct?
Yes. So there's some... I said yesterday I'd try and get the current... So a couple of versions back, you can run it fine. So there are binaries for there. Being a volunteer project, the person who was putting the binaries together has stopped doing that. No one else has stepped up. If anyone wants to, that would be a great thing for the community. RPy uses NumPy and SciPy on the back end, and so I think that some of the issues come from there, because if you've ever tried to install them on Windows, that's difficult in itself.
Right, it's time for maybe one more. I'll just cut the back here.
I was looking at D3, the JavaScript data visualization library recently. Do you think that in terms of engaging with the people who do the stats crunching, it would make more sense to engage someone to do something in R and then say, take the results and use it? Because on the website, JavaScript seems to be the way to do the graphing. Do you know of anyone who's looking at that, sort of bridging the two?
R and JavaScript.
Or D3, something like that. So
again, I'm not sure, but I'd be surprised if they weren't. So have a look.
Right, that's awesome. Thanks, Rhydwyn.